So we're going to have an academic and career panel. So we're going to first, I think, start off by introducing all of our panelists. So maybe we can start here with Duncan. You want to introduce yourself and kind of what you do, where you're from?
Sure. Thank you. Hi, everyone. It's a pleasure to be here. Thanks for having me. I'm Duncan. I'm a graduate student in bioengineering, working in a lab at Caltech.
Hi, my name is Mercedes Quintana. I'm a student here at PCC. That's it.
Hi, I'm Maitland. I also am a student here at PCC. I'm majoring in biology and doing research at Caltech and at PCC.
My name is Holly, and I'm a grad student at Cal State LA, currently in mathematics, but I got my undergraduate degree in mechanical and aerospace engineering at UC Davis.
All right, cool. Thanks. Let's start with Holly since she has the microphone. I think it's one interesting because a lot of us don't really know what you do as a mathematician graduate student. So maybe Holly, since you're in graduate school for mathematics, could you just tell everyone what exactly do you do as a graduate student whenever you're studying mathematics?
So at Cal State LA, I mostly take classes. I did do an independent study, which is like a seminar class that you can take with a specific instructor. Within your independent study, you can do research. And at the start of research, I think a lot of it is reading a lot of papers at the topic that you're interested in. So for me, it was graph theory. So I worked with a professor named Dr. Liu at Cal State LA, and she's the graph theory expert. So when I first started working with her, we had read a paper on anti-magic graphs, and we just talked about it. A lot of research papers, there's a lot of unspoken, they just sometimes go oh yeah, that's easy, or you should know that. And so it's a lot of unpacking, maybe a certain, the way they decided to prove something, or then you kind of go down a rabbit hole of oh, you gotta look at another paper and see what they did. So I think at the beginning it's a lot of reading, and then eventually you start to maybe, you decide to tackle a specific problem, and then you and your advisor start working together to see how far you can go. And you can also take the comprehensive exam, so if you don't decide to do a thesis and you're I will like to test out, you do have to take an exam to graduate. And so I decided to take the comprehensive exam route, but I did have the opportunity to study with Dr. Liu, and it's really fun, and it's pretty deep, so it's beyond just what you would do in class as a grad student, so it's fun. Yeah, it's pretty fulfilling.
And I think kind of a follow-up question, because I think one of the things you have to think of as a community college student is how do you get involved now to prepare you for the future, right? What can you be doing at a community college so that if your goal is graduate school at Cal State Los Angeles in mathematics, which I can think all of us can agree that's all of our goal here, right? How exactly can you do it, and what should they be doing now to kind of prepare them to get where you're at this stage of your career?
So I also went to community college before I transferred to UC Davis, and I think one of the things that really helped me, back then I don't think there were a lot of opportunities for community college students to do research or help out professors. So just having events like these, I think it really encourages students to do more than just what's in the classroom, but also visiting your instructors regularly helps a lot, because that's when I first went to office hours. And the more I went to office hours, the more I guess I saw professors as real people, and they were fun to talk to, and they weren't just instructors that you see in front of class. And so when I went to UC Davis and Cal State LA, it just became easier-ish. I know it's kind of, I think it's still kind of difficult sometimes to come go to office hours and talk to them. But I think, yeah, seeing your professors outside of class and just trying to connect with them kind of makes it easier as you go on to, if you're interested in what a professor is doing research on, it just makes it easier to like go out and reach out to them, even if you aren't like necessarily a student of their classes. But I think a lot of my other panelists have a lot to say about that as well.
All right, cool. So lesson is teachers are real people too.
Yeah, pretty much. I know it's like it's I don't know. For me, back when because I went to community college right after like high school, but it's just different, and like you have more freedom. But all you do is like see them teach, and so like when you go to office hours, it's fun. It's a good time.
No, and actually, I think that's actually really great advice, is to actually talk to your teachers and like what opportunities are available at Pasadena City College. Like a lot of faculty have things that they do that unless you ask, you're never going to be aware of. And so with that, we're going to go to Maitland. And maybe you could talk about like what are you currently involved with at PCC that maybe students here can get involved with opportunities that you've had over the last year?
Yeah, so I actually found out about Jared and all of your undergrad research through JAM, and I was connected to him, and so I went to one of the Saturday meetings, and a bunch of professors here came and talked about different researches that they were doing. And what was great is that there was such a wide variety, kind of something for everyone, and I am really interested in genetics, and Dr. Jorge Iniguez is studying genetics, and so I marched right up to him at the end of it, and I was like, I'm really interested in the work you're doing on the flies, and I'd love to be a part of it. And so now I've been working with him since last October, and we just went to Chicago and presented our research at a conference, which was really fun. And I am a biology major, but I've actually yet to take a biology class because of all the prerequisites to get into them. And so I was worried that I was never going to be able to get into any of the research things because I had literally zero experience. But from that, I was then able to get into an internship at Caltech, and now I'm doing work under a postgrad there. So it's been really helpful, and all you really have to do is just kind of go up to people and actually talk to them and ask them, and you'll be surprised with like how much they let you do.
And maybe to follow up on that, like what's the expectations from like faculty like me or Rodney Tollerson, who you're working with at Caltech, who's a postdoc? Like, do we have these really, really high expectations that you're going to win us a Nobel Prize in the future or something?
Yep.
Yes. But realistically, who can get involved with these research programs? Do you have to have a whole bunch of like experience, or just go and get in them and see what happens?
No, definitely not. Kind of like Mercedes, I actually came from an acting background, so I had absolutely nothing to do with biology, was not prepared for any of it. I'm very much in the lab going, what's this, what's that, like having him explain the basics to me, and they're like more than willing to do it. I think they're just happy that you're asking questions and you're involved and you want to be a part of it. It's not really about what you know, but how eager you are to know.
All right, well, and I think we'll kind of transfer to Mercedes here because you have a really interesting background of where you've sort of came from. Maybe you could tell them about like what originally did you get your degree in, and then maybe about how did you transition to a STEM degree and why?
Okay. Is it working? Yes? No? Yeah. Oh, okay. I learned about the violin when I was 5 and knew immediately that I was going to do that for my entire career. Obviously, that's not exactly what happened, but with those thoughts in mind, I did a bachelor's degree in performance and also a master's degree. During my master's degree, I hurt my shoulder, and I really wanted to perform, but I couldn't practice enough to like get those opportunities, and so that was pretty sad. But I saw Duncan here, who was in the engineering world, and who's also my boyfriend, so it makes sense that we are together. Like, I've seen him, and I saw everything that he was doing as very cool. We went to high school together, so he also did violin, and so the thought processes that he uses are very similar. So yeah, I thought that maybe something STEMmy could be for me. So around when COVID hit, I was like, this is a good time since everything sort of shut down performance-wise. And yeah, I've sort of been here ever since, doing the computer science thing.
And maybe, like, why did you choose a community college to start? And sort of what is your goal and how are you going to end up getting there eventually from a community college?
Okay. So still Duncan, he does research, which is so cool. And so I knew going to community college, which I picked because I could afford it, and it was very close to us, that I wanted research to be my eventual goal. And he does bioengineering, and I have heard through that how terrible stem cells are. So I was not so interested in that, but more interested in the computational part of his work. And did I answer all your questions?
Good.
Okay, cool.
All right, so now we'll move on to the boyfriend. So maybe, Duncan, could you give us maybe a background? Where did you go to school? What are you studying? Like, and what do you do at Caltech?
Sure, I'd be happy to. First, I want to clarify. I don't think stem cells are terrible, but
I think they're terrible.
they do take a lot of time to take care of. Okay, so I went to undergraduate in Colorado and did an undergrad in biochemistry, and then was able to take advantage of some research opportunities there, which helped me to eventually become a research technician in Chicago for a couple of years. And after that, I applied for a graduate program here at Caltech, where I'm now working in a lab that's kind of at the interface of biology and electrical engineering almost, in the sense that we try to think of cells as little computers and the proteins as interacting in the same way that circuit components might interact electrically. So we're kind of investigating new ways about thinking about the cell and designing things like logic gates or other more complicated circuits that could let you control what a cell does.
And going into Caltech, did you know anything kind of about that research, or was that something that you had to learn as you were going, like, to get your degree?
That specific research, I really learned a lot about it after starting the program. Yeah, I think much like our other panelists have said, like, what helped me a lot was just kind of like, I don't know, following my nose and going to seek out research opportunities kind of early and often in a variety of fields. Like especially, I think even after maybe your first year when you've taken general chemistry, if you talk to professors, they're often happy to have you work in their lab, and you can learn a lot by doing that. So that's kind of what led me there.
I mean, maybe just curious, how many people in here have thought about graduate school or thought about research or thought about transfer? Like, how many people would love to get sort of like a Caltech graduate school or transfer to get into a school like that? Like, can we probably agree that everybody would like that? Like, maybe, Duncan, what is really required if you want to make that kind of level or get into that type of school, or even getting into like a UCLA or an MIT or a school like that? Like, what advice would you give the students that are here in order to get that final outcome?
Right, yeah, I think, I guess my advice would be to especially look for places where you can start doing research early, and if you can find a lab environment where they really encourage you to ask questions so that you can learn a lot and eventually work on your own project toward a publication. Like, I know some labs might just want undergrads to like wash dishes or something like that. I'd try to steer clear of that sort of situation. But if you can really find a project and put together peer-reviewed publications before you apply for graduate school, that helps a lot. And then another thing that can help is sort of like what I did. After you graduate, if you get an undergrad degree, you can work as a research technician, and that can strengthen your application for graduate school if you want to get in.
And maybe we could pass it down to Holly and, you know, kind of the same question. Like, what did you have to do in order to get into graduate school at Cal State LA in math? And like, what sort of helped you get ready for that experience?
I guess when when I was at community college, I had thought, oh yeah, I would like to do mathematics when I do my undergrad. But at that point, I was kind of like pretty stubborn on just pursuing an engineering degree. But my time at community college was really fun, and I really enjoyed the math classes there. But I still decided to do engineering, and I don't think it prepared me as much. There's like, when you go from engineering to mathematics, I don't think there's a lot of there's not a lot of crossover. Like they give you the theorems or not the proofs, the statements and everything. They're like, you use this formula, but they don't really go over like why. So I guess that just planted like that curiosity, like I wonder like what's going on behind the scenes in these engineering classes, and that like propelled me to pursue mathematics even further. I worked after graduating, which didn't do much other than kind of seal my like I don't want to do engineering anymore attitude, and that further just I thought I would do mathematics, and it was totally fine to apply, but they didn't actually take me in the first time because they said you don't have enough math to come in. So I went to ELAC. I took some like other math courses that they said I should take, and that finally after that they let me in the next year. So the first time, I was like, oh my gosh, like I guess I don't have like enough math background. That was totally okay, and I just took that as like a sign to just really see at East LA College like the different like what is it that I was missing, and it was good. So that helped me get into Cal State LA.
And I think there's a really good lesson to learn here. Like, you need to be thinking now about what you want to do 4 or 5 years from now, right? Because what you don't want to have happen is end up to go into graduate school or applying for it, and then they come back and say, oh, you look like a great applicant, but you need to finish this class, or you need to finish Y experience. So having a plan of where you want to go now and looking at like, all right, what do I have to finish to get there and to apply there is really important, instead of waiting till like the very, very, very last second and then applying, and then they come back and say, sorry, we can't accept you until you finish this. So one thing I would encourage people is have a plan. Where do you want to transfer, and then where do you want to go to graduate school if that's something that you want to go? And I think I want to go to Maitland really quick to talk about time-wise, because everybody's busy, everybody has classes, everybody's working, everybody's got family, there's all sorts of things that we have to do. How do you balance working in a research lab at Caltech in the Drosophila project with also studying and like doing all of your work?
I will say that everybody that I've worked with so far has been incredibly understanding. I mean, if I have a midterm coming up or anything, they'll always say, go study, like that's the most important. And then same vice versa. My teachers know that I've been in the labs, and so, they're always there to offer a helping hand if I need extra time or anything. But also, as I'm sure people who've done a lot of research know, a lot of times it's kind of just waiting. Like, we're trying to grow some coal cultures right now, which can take months, or even just get like gels to set or anything, and you're sitting there for hours. So bringing your schoolwork with you, you have plenty of time to sit and do derivatives or study for chemistry exams. So,
yeah, I think that is a really good point. Like, one, I always tell my students they have to come to lab all the time and to ignore their classes. So, no. That's great. One thing I think would be interesting, does anybody in the audience have a question that they would like to ask the panelists at this point, kind of like halfway through? Anyone have anything that they would like to know? Yes.
I have one. So when approaching an undergraduate degree, and I guess taking courses that some of these courses overlap or intersect each other, and there's courses on a broader spectrum away from overall in general math that we know. What would be the best approach to, have a successful math career in college?
Maybe Holly, this would be a good one. What would be a good approach to having a successful math career in college?
Well, at least in grad school, I think I already said this before, but well, a couple of things. So definitely not being afraid to get help from your professors. Like as soon as you think you are not doing well, or if you're like concerned about like the material and your understanding of it, it's just good to just get help. And if you are feeling like I'm not ready to talk to my professors maybe at this time, I think finding like a good community, which is not unique to like studying mathematics, but I think the success of a lot of people in research or in their respective majors comes from just like finding like, you know, your study buddies or like a good group of people that you feel comfortable asking questions to and like collaborating with. Because I know for sure, like I love my time at community college, I love my time at Cal State LA, and I love UC Davis. But if I could change anything at UC Davis is maybe, you know, being more serious about my studies, but also, you know, just finding like just the people that you mesh well with and can feel comfortable like working together with. I think that helps like greatly, not just for math, but like when you're feeling maybe isolated, especially after the pandemic, it just helps to know that like, you know, you've got people who support you and people that are of like maybe the same age or people that you feel like you have similar interests with, that you just feel like, you know, supported in that way to succeed in all life, in all parts of life and academics. So.
Well, does anyone else want to tackle the question about math and how to do it? And Dr. Chang, maybe you would chime in here. Like, how would you answer that question? Like, how do you put math within your thing? And maybe, like, how many science majors here? Do we have all science majors? How many computer science? A lot of computer science people. Any math majors? You know, so like the thing about math is that it really is infused within all of STEM and even not STEM. I mean, there's all sorts of math out there. So maybe Dr. Chang, like, how do students in chemistry benefit from the math class, or what can they do with the math? And like, you know, how do we make it sort of exciting? Because sometimes math is hard and not exciting. So what can we do to make math exciting?
Well, okay, this is a very good question. We always try our best to help students to feel like math is natural. Actually, math is a language, and it's a universal language. How to make students feel exciting, I would say a lot of time, if you would like to become a manager, a boss, a CEO, you always want to make sure that you can transform some application problem into something that can be, you know, solvable. And we call that modeling. So if you have critical thinking, you know, well developed, I mean, throughout all those mathematical training, I think that will be a very good background for you to do that kind of modeling. So you can see that when mathematicians see problems, no matter whether it's from engineering, from social science, or from biology, sometimes they will be very quickly to see, oh, I know the structure. It is abstract. So I would say that those kind of abstract idea or concept is very, very important, and that apply to all fields. If you can get that kind of development, then you will feel very exciting, because when people give you a problem, then you will be able to keep rewriting or rethinking and making it equivalently to a mathematical model. I don't know whether that I make it clear to all of you, but I think it is very exciting.
All right, thanks. And I think what we're going to do, I'm going to go through each of them, and maybe you could give final thoughts, and then I'm going to make sort of an invitation if people want to participate in research at PCC and other places about what we have available. So maybe we'll just go down with Holly, then Maitland, then Mercedes. Duncan, like, what's the last thought that you would like to leave the audience as, you know, we sort of close this session, and hopefully give everyone about a 10-minute break, because it's been 2 hours now straight of kind of presentations.
I guess something that I'd like to share from my own experience is that whatever you decide now, it's like totally okay to change your mind down the road, as we've seen from our other panelists. And like, I know you might feel like I sure wasted maybe a lot of time, or maybe you're like, I wish I changed earlier or made up my mind earlier. But I mean, I just think, you know, whatever experiences you develop from whatever you're pursuing now will definitely like help you as you make a different decision and decide to change, you know, the direction in your life. So I just want to, you know, like we have like goals right now, but it's okay if it changes. And, you know, I encourage you to, like, if you feel like, oh, I have different dreams later down the road, I encourage you to pursue them. And, you know, I wish you all the best.
Yeah, kind of piggybacking off of what Holly said, try and get into as many research internships as you can, because I've been really fortunate that I've actually really enjoyed and been very interested in everything that I have done, but I think it can be kind of hard to tell just in a class what is exciting, like what sounds exciting on paper may not actually feel that exciting when you're trying to apply it in the real world. So not only is research a great opportunity to find what you like, but it's also a great opportunity to find what you don't like, so that maybe then when you do enter into grad school, you'll have a better idea of it because you've already done it. So I would just seize every opportunity, even if it doesn't seem like something that you'd be interested in, you may end up really loving it. So, yeah.
I guess for me, it would be about reaching out to your community, especially when I started taking math classes after getting 2 degrees without any math in them. Let me tell you, that was hard. But because I went to office hours and was really open about the fact that I wasn't 100% sure what I was doing, I was astonished by how the community really helped me understand like dividing fractions. I still remember on my first test that I didn't know how, so I made it up, and it was okay because I was able to figure it out. Sort of going back to the idea of looking at opportunities. My internship when I first came in was actually for geologists, and I am a computer science major, and what they had us do was look at dirt and actually map the fractures from an earthquake from it, which was very cool if you are very into dirt, but I was a little bit less into dirt. But because of that, I was able to sort of leverage this opportunity into playing with machine learning through cluster analysis and starting a new project that was actually building an algorithm. So yeah, I guess my final thoughts would be connecting to your community, like especially Dave. He's always got so many things going on if you are a computer scientist, Dave Smith. And yeah.
Yeah, and I guess my final thoughts would be to, especially if you want to go into research, not be afraid to take a lot of chances and fail at things, because I think almost every experiment, the first time you do it won't work, but if you stay persistent, you can finally, you know, learn some new thing. And the same thing goes for, I think, applying to new programs, internships, research opportunities, graduate schools. Like for instance, I applied to many graduate schools that I didn't get into, even though I did end up getting into Caltech. So I think just stay persistent and you'll eventually meet your goal.
All right, cool, thanks. Now, some of the things that we have at Pasadena City College that you can get involved with. Currently, we have 13 students who get $10,000 stipends to do research year-long at Caltech and USC. That's a program that can be around for the next 2 or 3 years, maybe 7 if my grant gets renewed. Like if students are interested in doing year-long research, to be honest, the way that I picked the 13 students, it's the 13 students that showed up. Like, that's all it took. They came to our Saturday research sessions, which are from 12 o'clock to 4 o'clock, and they kept on coming. And so whenever the opportunity showed up to, hey, I can get internships at Caltech for you and get you $10,000, I picked the students that showed up. We have another internship program that basically is a year-long micro nanotech internship program that gets $3,000 per student. There's 50 spots for that one. And again, kind of the same thing. You have to reach out to the faculty members and ask and learn about it, because if you don't ask, like, no one's going to tell you. We also have the Caltech Connections program, which actually 30 students right now are shadowing Caltech postdocs and graduate students. They get $600 for the semester, and that's going to keep going on continuously with Dr. Scott Cushing and Tiffany Komodo at Caltech. So Caltech has now formed this very strong partnership with us, and if you're interested in doing a kind of an internship program with them, the best thing to do is, contact us. So whenever the applications come out, we can tell you. But even better is, every Saturday from 12 o'clock to 4 o'clock in E104, we open up our undergraduate research lab. So you can come over there and build the ROV. We have an underwater robot. We do the nanobiotech project. So we have projects that students can do. And for faculty that are here and want to get involved, we would love to have faculty come during these sessions. Like, we would love to get more than, Dave Smith comes, I'm there, Dr. Chang's there. Occasionally we get some other faculty, but if more faculty want to get involved, it doesn't have to be every Saturday. You can come once or twice a month. Bring research projects that students can work on, right? And I promise you, if you do these research projects and if you participate, you will get outcomes. Right? Like, you'll get publications, you'll get papers, you'll get other internships, because the first one leads to the next one. Like, if you never ever get that first one, you're never going to get the second or third one. Right? So if anyone's interested, please email me or just show up on Saturdays at 12 o'clock in E104, and you can come and kind of see what we do. So with that, thank you to the panel. Thank you, Dr. Chang, for having an awesome Pi Day. She puts this together like crazy and does an awesome job. And now we can have a 10-minute break.
Of course. Thank you, everyone.
So, should I just set up?